Okay, so take a look around you. I mean, really look. At your tools, your watch, maybe even things you'd never suspect. You are surrounded by this hidden technology. It's like a microscopic layer of armor that makes our modern world tougher, stronger, and way more resilient. So, what is this invisible force? Well, let's dive in.
So let me ask you this. What in the world could possibly connect a heavy-duty industrial drill bit, the kind that chews through steel, with a super delicate dental implant that's designed to be a part of the human body? The answer is actually way more fascinating than you might think.
The secret is that both of them are protected by a kind of invisible armor. We're talking about an ultra-thin coating, applied with just incredible precision that gives them properties they could never ever have on their own. And the process behind all this magic is called Physical Vapor Deposition, or PVD for short. So, how does this even work? Imagine you're spray painting, right? But instead of paint, you're using individual atoms. It's wild. Inside a vacuum chamber, a solid material gets vaporized into a plasma. And then, those atoms condense onto a surface, building up a brand new layer, literally one atom at a time. The level of precision here is just mind-blowing.
Now, this technology isn't exactly brand new. The whole story really started with one revolutionary coating that kind of set the standard for everything that came after, and it became famous for its really distinctive color.
Yeah, back in the 1980s, titanium nitride, or tin, just burst onto the scene. And I guarantee you've seen it without even realizing it. It's that brilliant gold color you see on high-end drill bits and fancy tools. This stuff was the original game changer. And tin was revolutionary for a really good reason. That gold color? It wasn't just for looks. It dramatically increased the surface hardness, which meant tools could cut faster and last so much longer. It made them super resistant to rust and wear, basically turning them into industrial workhorses for everything from massive factory floors to delicate jewelry. But you know how it is. Science never stands still. As amazing as tin was, researchers knew they could do more. They wanted a whole new palette of materials, each one specifically tailored for even more demanding jobs. And this quest led to the development of coatings like Titanium Carbonitride, or TiCN. I mean, just look at the difference. It was a huge upgrade across the board. Superior hardness, way better wear resistance, and much higher thermal stability. This new coating could handle the intense, high-performance cutting jobs that would have just destroyed the original TiN. And from there, the toolkit just kept expanding. Pretty soon, there was a whole family of these nitride coatings. Zirconium nitride, chromium nitride, you name it. Each one offered a unique combination of color, gloss, and mechanical properties. It meant engineers could finally pick the perfect armor for any specific job. Okay, so everything sounds perfect, right? Well, not quite. There was a problem. Even these super hard coatings had a weakness. A single, ultra-thin layer, no matter how hard it is, can be pretty fragile. So, the next big innovation was about building smarter, not just harder.
And here's the core challenge they were up against. Under really intense stress, the kind you see in industrial cutting, these single-layer coatings could be brittle and just crack. And a crack in the armor, no matter how tiny, is a point of failure. That's a big deal.
The solution they came up with was brilliant and honestly pretty simple in concept. Don't just use one layer, use many. They started building these composite stacks, alternating different materials like tin and aluminum nitride. You can think of it like creating atomic-level plywood, where each layer gives strength to the others.
And the benefits of this were huge. This layered structure makes the whole coating so much tougher. If a tiny little crack starts to form in one layer, it gets stopped dead in its tracks when it hits the next layer. This prevents a catastrophic failure. These interfaces also help spread out stress and can even act as a chemical barrier, which adds a whole other level of protection. So the next evolution was to take this control down to the nanoscale. I mean, even smaller. Researchers developed what are called nanocomposite coatings. These are less like distinct layers and more like an incredibly fine-tuned mixture of materials. This gives them precise control over properties like friction, and as we're about to see, this is absolutely crucial for how these coatings interact with the human body.
Okay, so we've covered the how. Now for the really exciting part, the why it all matters. Let's take a look at the incredible impact these tiny layers are having on our world, from giant factories all the way to inside the human body. In an industrial setting, the difference is just staggering. An uncoated tool might wear out after just a few hours of work, but you apply a PVD coating, and suddenly its functional life can multiply.
For a factory, this means way less downtime for tool changes, more precise cuts, and ultimately, massive savings. It's a total game changer. Now let's circle back to that dental implant from the beginning. For medical devices, PVD coatings are absolutely critical. They protect titanium implants from wear and corrosion once they're inside the body. They also make sure the implant is biocompatible. And get this, different colors can even be used to help surgeons quickly identify different implant sizes and types during surgery. And the applications are just incredibly widespread. It goes way beyond industrial tools and biomedical devices. PVD adds that durable, high-end finish to decorative items. Think premium watches and faucets, and it even enhances the performance of advanced ceramic components. It's truly a hidden technology that's part of our everyday lives.
It's really incredible when you stop and think about it. We're talking about layers that are thinner than a single human hair, but their impact on technology, manufacturing, and medicine is absolutely massive. This is nanotechnology in action, literally changing our world from the atomic level up.
It really makes you wonder, doesn't it? If we can already do all of this, from making a drill bit last 10 times longer to improving the safety of a medical implant, what are we going to transform next with this atomic level armor? The possibilities, well, they're really just beginning to unfold.